Okay, so we are now going to talk a little bit about area between curves, which we've seen before when we first started talking about integrals and areas. We mentioned the idea of having a curve, and once we had that curve, we drew all kinds of rectangles underneath it. So we might have drawn these little rectangles underneath here, right? And we use that sort of Riemann sum idea to calculate the area under a curve. Well, as you know, most things do not have sort of this straight line boundary at the bottom. So instead, we will draw this with sort of two curves, right, that we might have. So let's say we have a curve like this, and we have another curve, maybe it looks like this, and we want to calculate the area in between here, like all of this here. So in order to do that, right, the idea is that we would just kind of calculate the area of the taller curve using our rectangle idea, and then calculate the area of the shorter curve, right, so this one here, sort of this, the area underneath here. Right, and then if we subtracted the red from the green, right, we would get the total area of just what's kind of on the inside here. So that's kind of what this formula is saying about area between curves, is that we're going to take the bounds a to b, and we're going to take the top function and we're going to subtract the bottom function, and then integrate that with respect to x, assuming that we're going vertically as we integrate. So our first step then when we do these curves is to, if at all possible, the great thing that you should do first, if we have the chance, is to draw a picture and decide on what the top curve is. And so that's an important piece because we need to know, right, which one we're going to subtract higher from minus the lower. And then you just need to find your bounds, and that's generally where those curves intersect, so your A and your B. And then I would say we'd have a third step, which is then to integrate and get the area. So that's kind of the process of finding area between curves, is we're going to draw a picture, we're going to decide what the top and the bottom is. If you can't draw the picture, there are other ways of trying to decide what the top and bottom are. We'll look at some of those examples, and then we will find bounds from A to B. So here is our first example, and maybe we'll start this on a new page, but we're going to sketch the region enclosed by the given curves and then find the area of that region for y equals x plus 1, y equals 9 minus x squared, x equals negative 1, and x equals 2. So let's try that now. Alright, so here we have our region that we're going to try to sketch and find the area of. So we'll kind of draw our picture. That was what I said our first step would be. So x plus 1, if we plug in 0, we're going to get 1. If we plug in 1, we're going to get, I think, 2. So this thing is looking something like this. And then we're going to draw 9 minus x squared. So let's draw that in a different color. So that's going to intersect, I believe, if we plug in 3, we're going to get 0. And if we come over here, a little bit too far away, and plug in 0, and it's going to face downward. Similarly, if we plug in 0 for x, we're going to get a 9, so it's going to be kind of way up here. So this thing is going to do something like this. And again, I'm not drawing it exactly perfectly because I kind of use the edge of the paper here. But the idea, hopefully, and it's going to also be bounded, we have two other bounds by x equals negative 1, which is over here, and x equals 2. So we want the region that is bounded by all four of those curves, which looks to be this sort of section right here. So to be a little bit careful about deciding what your region is. But now that we've kind of seen that these four curves, the two straight vertical lines, along with the parabola and the linear line, form this little region right here. So now as we try to come up with the integral, the thing that we're going to integrate, we'll take the integral, we'll figure out the bounds in a minute, we'll figure those out. But we'll take the top curve, which looks to be the parabola, the red curve, so that's 9 minus x squared. And then we're going to subtract x plus 1. And this is all with respect to x. And now the question is, what are our bounds? So what's the furthest sort of left that we're starting? And that would be negative 1. And what's the farthest right? That would be 2. So from -1 to 2, we have our function, we have subtracted. These parentheses are really important, right? Because you want to subtract the whole thing, not just some part of it. So now you're ready to find the sort of final answer here in the area for this thing. Let's just mark this other example out. So we have 9x, if we integrate that, minus 1/3 x cubed. This is going to become minus x squared over 2. And if we're careful here and distribute our negative, it's going to be minus x. And we'll evaluate that from -1 to 3. So that means you're going to plug in 3 all the way across, and then we'll plug in -1 all the way across. So 27 minus 1/3 times 27, minus 9 over 2, minus 3, and then all of that is minus, again, these parentheses are very important, -9, plus 1/3, minus 1/2, and then plus 1. And so if you calculate all of that out, we would have to do a little bit of arithmetic here. So it looks like we're going to get 27 minus 9 minus 3 minus 9/2 plus 9 minus 1/3 plus 1/2 minus 1. So if we calculate all that out, looks like possibly these 9's cancel, and we're going to take 27 minus 3, which is 24, minus 1 is 23, so it looks like we get a 23, and then minus 8/2, which is minus 4, so that's 19 minus 1/3 maybe. So 18 and 2/3 would be our answer for the area in this little region. So that's our first example. We'll look at a few more examples in class next time, but hopefully this gets you a start on thinking about area between curves.